Now we're going to look about vectors from the perspective of geometry. So a vector is a specific quantity drawn as a line segment. This is from the book, by the way. With an arrowhead at one end, it has an initial point where it begins and a terminal point where it ends. A vector is defined by magnitude, or the length of the line, and its direction, indicated by an arrowhead at the terminal point. Thus, a vector is a directed line segment. That's a key point right there. It is a directed line segment, and known by its direction and magnitude. So if you, I'm going to put in our series of videos here a clip from Despicable Me, where he talks about the guy Vector introduces himself because he's doing crimes with direction and magnitude. So I think that's kind of a nice thing to tie in to those who have seen Despicable Me. Okay, there are various symbols that distinguish vectors from other quantities. You would get, like, usually it's going to be a darker letter, a bold-faced letter, I should say. V, U, W are common. V with an arrow on top, U with an arrow on top, W with an arrow on top also would be vector notation. Could be, if you know the initial point's P and the terminal is Q, P, Q with this line over it. So notice that the initial part's over the P and the arrow's over the Q. That would be another way to notate a vector. Given an initial point of 0, 0 and a terminal point of AB, the vector may be written as, so instead of parentheses or brackets, you get these kind of arrowed looking brackets there. So this last symbol has specific significance. It's called the standard position. The position vector has an initial point of 0, 0 and a terminal point of AB. To change any vector into a position vector, we think about the change in the x-coordinate and the change in the y-coordinates. Thus, if the initial point of a vector is CD, where C is at x1, y1, or vector CD, where C is at x1, y1, and the terminal point is x2, y2, then the position vector found by calculating the AB gives us that. We could then move that down. So like this would be moved down 2 over 2, and this was moved down 2, left 2 as well. Okay, so with that, consider the vector whose initial point is 2, 3 and terminal point is 6, 4. So 2, 3 and then 6, 4. So there's our PQ. But for the position vector, we can move, what do we have to do? Move this down 3 to the left 2. Move this down 3, 1, 2, 3 to the left 2. And we would get this vector here, which would be 4, 1. So it goes over 4, up 1. Likewise, find the position vector. Given the vector v has an initial point at -3, 2, and a terminal point of 4, 5, then graph both vectors in the same plane. So -3, 1, 2, 3, 2, to 4, 5, 1, 2, 3, 4, up 5, 1, 2, 3, 4, 5. Okay, and then we'll graph the position vector. So that has to go down 2 to the right 3. Down 2 to the right 3. So down 2 for this. To the right 3 is there. That would be 7, 3. That's it.